Hi guys, in this second video we are going to cover the topic of linear space and operation. I'm going to ask you some questions about this specific part because that's a part of NumPy which is going to be very useful in the future. Let's start by linear space. A linear space is an equation, is a mathematical equation which is based on ax plus b. And what we are going to try to do here with NumPy is to ask NumPy to provide us some values which are going to follow this type of operation, which means some linear values. This request is going to be very useful in the future, mainly if you want to automate a testing, or if you just want to have like some values which coming with a linear way, which means like with the same space between the values. For instance, and how does NumPy works? If you select you will have to select a value A, a value B, and in between you will have to select the number of values that you want. You will need three arguments: value A, value B, and the number of values in between. For instance, in NumPy, if you want a value linearly spaced between 0 and 10, what you're gonna have to define first. You're gonna have to define as your value A 0, as your value B, that's gonna be 10, and in between you will have to choose the number of values that you want. For instance, if you want 3 values, NumPy gonna provide you 0, 5, 10. If you want 5 values, NumPy gonna give you 0, 2.5, 5, 7.5, and 10. Okay, I believe it's enough talking for this first application, and let's try to apply it. If you want to do that, as I explained you, first of all you're gonna have to set up your A value, or X. I'm going to call it X right here. Then your Y value, which is 10. After that, the number of values that you want in between, which is going to be 5. And if you want your matrix composed by this type of value, you're going to have to type matrix equal numpy.linearSpace and these 3 arguments. You can have more information by typing shift enter. You're going to have all the information that you need. You need your start. And if you look in our board, the start is the point A. You will need your stop, which is here the point B, and you will need the number of values. Automatically, NumPy gonna set up the number of values as 15, and if you want to change it, you're gonna have to give your arguments. Either you can type num equal nbval, or if you don't type num, NumPy gonna recognize it as third argument and automatically set up to num. Okay, once we are good with that, we're gonna have to print our matrix afterwards and execute. Let's look what we have. Perfectly, we have a matrix linearly spaced, which following this simple equation ax plus b. It's basic equation. Now, if you want to try different arguments, for instance, if you want to have 8 values, you can execute. You're gonna have 8 values between these 2 bounds, which means like between 0 as a lower band and 10 as a higher band. And now we can give it a try with a different option. For instance, if we want to do it even more effectively, it's not necessary to define it as x, y, and number of values. What you can do, you can just like copy this line, paste it, and instead of directly calling x, you can just directly set up your entry point, for instance 30, your out point, which for instance can be 76, and the number of values in between. For instance, if you want 21 values, not in between, but the total of values. Execute, and you will have a linearly spaced matrix using entry, outpoint, and the number of values in between. And you can make it even bigger. For instance, if you want something a little bit more complex, you can do something like that, like for instance between 30 and 34, or between 0 and 14, or between 0 and 12. I want 150 values, and if you execute, you will have 150 values between 0 and 12. It's some basic knowledge, but that can always be useful, mainly if you want to try some more complex algorithms, or if you want to go beyond in terms of NumPy. That's a function that I'm using very often when I want to automate, or when I need like different values between two bands. Okay, we have just finished covering the linear space, and in order to close this second part for NumPy, we are going to talk about operation and how we can have different operation values with NumPy. Okay, first of all, before to start making an operation, what we are going to do, we are going to create a randomized array. I believe right now you must be good with how to create a randomized array. We are going to use a randomized integer between 0 and 100 just as an example. Let's execute. Okay. If you remember well, just like a quick recap, if you want a randomized array, you have to select your lower band, your higher band, and the number of values that you want. I want 10 values between 0 and 100, or like, let's say, yeah, between 0 and 1000, and I want 80 values. Can execute. Yeah, as you can see, that's a little bit messy. You can't really read what's happening inside. And what we are going to do right here, we are going to ask NumPy to print us different mathematical indicators about what's happening inside this list. Essentially, this type of operation is going to be very useful when you will need to have some information about the standard deviation that you have inside your series, inside your time series. When you will need to know more about the mean, the average, about different percentile, about your variance, about the mean, the max of your values. Essentially, what we are going to do right here is to print this different simple operation. You can have it in the file attached to this video. We are going to first of all print the max, then the mean, the average, the standard deviation, the variance, and just as a checking, we will check if our standard deviation is equal to the variance. Is equal to the variance, because if you go on Wikipedia, or like if you have some basic mathematics knowledge, you must be aware that the standard deviation is the square root of the variance. And let's give it a try. Let's execute. As you can see, the standard deviation is not exactly equal to the variance because that's rounded. But if you look at it, you can notice that NumPy automatically gave us the max value inside this population, which is 972, the mean value, which is 0, the average of the list, the standard deviation, which is in the list, the variance, and we double check by checking if the standard deviation is equal to the variance, and as you can see, that's equal. Okay, and just just gonna give you a quick recap on strings right now, just before to close this second part, and I believe that's always good to have a quick recap. And what we are going to do here, we're just gonna type a quick sorry, in lower cap, a quick recap on strings. What we are going to type is a small text which is gonna say the average, or no, sorry, let's say the variance of my array is, and give the value. And as you can remember, what you have to do always, if you want to add two strings, you have to convert it as a string, which means we are going to convert this value as a string, and we're gonna print it. Up. And if you click here, yeah, the variance of my array is 68,202. And we can rerun our randomized array. We're gonna have different values, and rerun this sentence, and as you can see, the variance has changed. Okay guys, that's all for this part, which covered the linear space. To make a quick recap, the linear space are following this simple equation on NumPy, which means you have to set up a lower band, a higher band, and how many values you want in between. In order to do so, you have to call numpy.linearSpace, set up linear band, lower band, higher band, and the number of values. And the second part was on the operation indicator, on mathematical indicators such as max value, mean value, average, standard deviation, variance, and how to get it. And in order to get it, you just have to type your array .max.min, .minimum, .min, .standard deviation, or .variance, and you will get all these values. And here a small recap on how to use string, and don't forget to convert it as a string, because otherwise, if you don't convert it as a string, you will get the following error. Okay, in the last part of this NumPy exercise, we are going to talk about multidimensional arrays with NumPy, which means when you have a two-dimension arrays, and how to locate and filter your array. I wish you good learning, and see you in the next video.